welcome to Math Master. This is Saritha. Today we are going to learn circles and tangent topics. Okay, we have seen in the last class. We have seen about chords, arc, segment, and sector. Okay, so what is a chord? A chord is nothing but it is a line segment joining any 2 points on a circle, isn't it? Now we have to see one condition which always holds with the case of two chords. Means when the two chords intersect, one condition holds always. So that condition we will see now. Okay. This is a circle and now you draw any two chords. Means we have to draw two intersecting chords. Means some chords may be parallel, right? So we should not consider the case of parallel chords. You take any two chords, the possibility you should have is that those two chords must intersect at any point. Okay. Now I am considering any two chords, which is nothing but this is a chord AB and this is a chord CD. Okay. So see, you consider two chords. Those two chords intersect at any point. So the point we call it as a point P. Okay, this is an intersecting point of two chords that we call it as a point P. So will it always be the same case every time? No, right? Because those two chords may intersect interior of a circle or those two chords may intersect at any point on the circle or those two chords may intersect outside the circle also. So in all cases this condition holds. Okay. So what is that condition? So if this is the intersection point of the two chords, so we have to see this PA and PB are parts of the chord AB, isn't it? And PC, PD are parts of the chord CD. So if you take product of the parts of the chord, which is nothing but PA into PB, these two are parts of the product of the parts of the AB chord. Okay, which is always equal to product of the parts of the other chord, which is nothing but PC into PD, right? PC into PD. This condition holds always true with two intersecting chords. Okay. Just now we have discussed that the point should not always be interior of the circle. Sometimes it may be on the circle. Sometimes it may be outside the circle also. How will it be outside the circle? Now we'll see. See, if you consider a circle like this. Okay. If this is one chord, if this is a chord AB and this is a chord CD. Okay. These are two chords. We extend these two chords, means if you extend these two chords, those two chords will intersect at point P, which is outside of the circle. Means these two chords intersect at outside the circle. Okay. So in this case also this property holds. Okay. So how can you write? So you have to start with the point P is the intersection point of the two chords and you should consider PA as a one part and PB as a another part of a chord, isn't it? So actually this PB is the total length and PA is a part of a length. So you have to take those products, which is nothing but PA into PB, means you must start with the point intersection point P. Then you have to write those distances. Okay. So this is nothing but PA into PB is equal to PC into PD. Yes. PC into PD. Yes. This is the case where two chords intersect outside the circle. Okay. And if you see another case, which is nothing but if this is a circle and these are the two cards. This is a AB card, this is a CD card, and this is the intersection point of these two cards, which is, we call it as a P, isn't it? You observe here the intersection point and one end point of AB card and one end point of CD card all are coincide at one point, isn't it? Yes. So if you write this condition with this case, which is nothing but PA into PB. See, PA into PB, which is equal to PC into PD. PC into PD. So this condition holds always with the two intersection cards. Okay, you have to remember this, and this will helpful you while solving the problems. Okay, now we'll see what is a secant line. A straight line joining any two points on a circle. See, this is a circle, a line. The first of all, the secant line is nothing but it is a straight line joining any two points on a circle. See, if you take these 2 points, any 2 points on a circle, if you join a straight line, which is, if you draw a straight line which is joining the 2 points on the circle, and this line we call it as a secant line. Secant line. See, you observe the difference with the chord and secant line. Chord is nothing but it is a line segment joining any 2 points on a circle. Secant line, it is nothing but it is a straight line joining any 2 points on a circle. Here the secant line, we can extend this line infinitely on both sides. But when you come to chord, now the length of the chord we can easily define. Yes, means the end points of the chord always on the circle only, isn't it? So this is a secant line. Now you tell me, how, if you consider any point on a circle, how many number of secant lines can you draw? Now we'll see. See, if I consider this is a point P, okay, I am taking only one point, that is a point P. So yes, I am drawing one secant line through this point. Like this, how many secant lines can we draw? Now we'll see. So if I draw like this, isn't it a secant line? Yes, it is. And if you draw like this, what about this? This is also a secant line. Like this, if you keep on drawing secant lines through any point on a circle, you will get an infinite number of secant lines. Okay. Our next definition is tangent line. What is a tangent line? Tangent line is nothing but if you draw a line, that line must cut the circle or must intersect the circle at only one point. See, so this is a circle. I am drawing one line. That line must cut the circle at exactly one point. See, if you take this is the point. See, you take this circle. This is the one point on the circle. If you draw a straight line which cuts the circle at exactly one point, then we call this line as a tangent line. Means this line must cuts the circle or intersect the circle at exactly one point. Okay. So this we call it as a tangent of a circle. This is a tangent of a circle, and this point we call it as a point of contact. Means the point where the line touches the circle. So this is the point of contact. Okay. Now you tell me, If you consider any point, so how many tangent lines can we draw through that point? We'll see. Okay. See, if this is a circle, I am considering one point which is exterior of the circle. Means the point is completely outside of the circle. Now you tell me how many tangents can we draw through this point? See, we have to draw. You try to draw tangents. If this is a point P, see, and as this line touches the circle at exactly one point. Yes, yes, it is a tangent. And if this is also a line, which is PB line, this line also cuts the circle at exactly one point. Yes, this PB line is also a another tangent. So, and if you try to draw any other tangent through this P, is it possible other than these two? It is not possible to draw more than two tangents with the point exterior to the circle. Means if you consider a point which is exterior to the circle, we can draw exactly two tangents through that point. Okay. What happens if this point is on the circle? Now tell me how many number of tangents can you draw? Now we'll see. If this is a circle, see, this is a circle and this is the one point I am considering. The point is P. Okay. Now you try to draw tangent through this point. So the tangent definition itself tells us that it must touches the circle at exactly one point. And that point itself on the circle, and we should draw a line which must pass through this point. So this is the only one tangent that you can draw through the point which is on the circle. Okay. Now you tell me, if you consider that point interior of the circle. So if this is a circle, you consider the point which is interior of the circle. Now you try to draw tangents through this point. Is it possible? No, it is not possible to draw any tangent through this point which is interior to the circle. Okay. The position of your point. If the point is, the first case, the point is exterior of the circle, right? Exterior of the circle. Then how many number of tangents can you draw? You can draw exactly two tangents through that point. Yes, two. And if the point is on the circle, if the point is on the circle, how many number of tangents can you draw? You can draw exactly one tangent through that point. And the third case is interior of the circle. If the point is interior of the circle, how many number of tangents can you draw? So we can draw 0 tangents. Okay. So this is what? If your point is exterior, we can draw 2 tangents. If the point is on the circle, you can draw 1 tangent. If the point is interior of the circle, you can draw 0 tangents. Okay. Okay, we will discuss the properties of the tangents in the next video. Thank you.